Hi folks, welcome to 9.5, and today we'll be talking about matrices and matrix operations. So let's start with what we know. All right, so what we know. Things we've talked about in chapter 9 so far include a lot of solving systems of equations. And in particular, we've looked at solving systems of linear equations, and we've looked at solving systems of nonlinear equations. Okay, but for both types of systems, we've looked at solving them with graphing, substitution, and elimination, right? No matter whether it's linear or nonlinear, we can graph them, we can use substitution or elimination or some sort of combination of those, right? And as you may remember from the linear equation systems, we looked at those with 2 and 3 variables. Okay, so we looked at 2 variables and 3 variable systems. And while some of the 2 variables, most of those were things that are familiar with us, things we've seen since maybe middle or high school, the 3 variable systems got kind of gross sometimes, okay? And so you can imagine that if we had looked at a 4 variable system or a 5 variable system or a 200 variable system, that doing it by hand might get really tedious, all right? Now, one thing we also learned in 9.4, we took a look at partial fraction decomposition, and we used systems of equations in there to actually solve for each of the partial fractions. Okay, so the theme here so far in this chapter has really been systems of equations. Now, what's new? So in this section, we're going to take a look at something called a matrix, okay? So matrices is really plural for matrix. So if you have one, you have a matrix, but if you have 2 or more, you have matrices, okay? And we're going to take a look at some of the very fundamental things about matrices in this section. So we're not actually going to get to a ton of the applications, but rather we're going to look at adding and subtracting them. We're going to look at scalar multiplication, and we're going to look at how we multiply matrices, okay? And I'm going to say that probably most of our mental space will be left for this last section, multiplying the matrices, okay? I will talk a little bit about some extra credit options because as you noticed, we talked a lot about solving systems here, and I'd love to leave it for you to take a look at how we might use matrices to actually solve these systems, okay? All right, so let's get started with some definition and usages. So when we see a matrix, all right, we usually see it with sort of these square brackets. And inside the square brackets, we have a lot of entries, okay? And so it turns out that we need to be able to describe the size of the matrix, okay? And so we often call that dimension, but the way we describe the size of a matrix, all right, is we look at the, let's choose a better color here. We choose the M, and M talks about the number of rows, all right? So 1, 2, all the way down to M rows. So the rows are the ones that go across. And we want to count how many of those we have, but then we also want to count how many columns we have. And that would be like 1, 2, all the way to n columns. So the columns go up and down and the rows go across. And that would be one of the most important distinctions that we know when we're describing how large a matrix is, okay? So we would say that this is an M by N matrix. And we also say that each of these in here, our A, I, J, those are entries inside of there, okay? All right, now, I'm not going to talk too much about the uses here, but I think it is important to know that what we're doing here is all fine and good, but really we're learning the underpinnings of how some of the stuff that we might learn later on in our mathematical careers actually works. And so in particular, we use matrices a lot to solve systems of equations. And we use that in a lot of higher math when we are looking at systems that maybe have like 10, 11, 12, 100, 200, a very, very large amount of variables, okay? Now, if you're interested in thinking maybe like, well, how would I ever use this in a career? It turns out that when we do a lot of graphics and animation, we use systems of equations to help maneuver all of that. If you're thinking about looking at any sort of data science, statistics, any of that sort of thing, working with large data sets, and we're talking like tens of thousands of entries, matrices is usually a really nice way to organize your data. And finally, if you're thinking about going into some engineering of any sorts, we actually use a lot of matrices to help define the motion that robots make, but also to help guide aircrafts. All right, so lots and lots of applications for matrices. Super cool idea, and we're just going to start here with just some of the basics in this video. Okay, so the basics. We want to know how large a matrix is, and we want to be able to find particular entries in a matrix. Okay, so given the matrix below, answer the following questions. Here's our matrix A. All right, now we usually use an uppercase letter here to talk about a matrix. So we won't ever call it like lowercase a. It'll always be an uppercase letter. And so in this matrix here, all right, let's go back and see what we have. But how many rows does this matrix have? Well, it has 1, 2, 3 rows. And how many columns does it have? Well, 1, 2, 3. Okay. So if someone were to walk up to you on the street and say, name the dimensions of this matrix, you would say that it has 3 rows and 3 columns. So it is a 3 by 3 matrix. Okay. And again, this 3 for the columns is the second number, and the first 3 is actually the rows. Okay. So you would say, oh, my friend, this is a 3 by 3 matrix. Okay. Now, question B, it says, what entry is at A31? And we don't read this as 31, okay? It's not A31, but rather the 3 talks about which row it's in, and the 1 talks about which column it's in, okay? So what I want to do is go over to my matrix. I'm going to go to the 3rd row. So I know I'm going to be looking in this row, and I'm looking in the 1st column. So that's going to get me here. So we would say that A31 is really 3 because the entry in the 3rd row and the 1st column is 3. Okay, let's practice that again over here. Remember, this is not saying entry A23, but rather it's saying entry in the matrix in the 2nd row and the 3rd, I didn't want to do that, and the 3rd column. Okay, so the 2nd row and the 3rd column. So the 2nd row is here and the 3rd column is here. So the number in the intersection of those is 7. So we can say that A23 is 7. Okay. So making sure we know how to find the dimensions and where the entries are, keeping track of which one's a row and which one is a column is super important, okay? All right, let's try another example before we finish this video. So given the matrix below, answer the following questions. So now we have a matrix B. And to be really correct, I really should have called this B31 and B23, okay? But what are the dimensions of this matrix? Well, let's count how many rows we have. 1, 2. And let's count how many columns we have. 1, 2, 3. So we have 2 rows and 3 columns. So we have a 2 by 3 matrix. All right. So we can see that it has a different size than matrix A because it has 1 fewer row. We only have 2 rows this time instead of 3. All right, now let's find out where these entries are. What entry is at B31? Well, this means that I am going to the 3rd row and the 1st column. So row 1, row 2. Well, I don't have a row 3, right? There's no 3rd row here. There's no 3rd row. So B31 does not exist. Okay. And I wanted to show us this problem because I think it's important that we realize we have to be able to count the row and we have to be able to count the column. And if we switch those numbers, right, it's not the 3rd row and the first row and the 3rd column. That might be 3, but it's the 3rd row and we don't have one. So it's okay to say that it doesn't exist. Okay. All right, let's take a look at C. What entry is at row 2 and column 3? All right, row 1, row 2. Okay, so I'm looking, it's going to be either 2, 0, or 4. And which entry is in the 3rd column? Well, 2nd row, 3rd column is going to be 4. So B23 is 4. Okay, so most important things about this, making sure you know the first number is the row, the second number is the column, and then going ahead and finding out where those entries are, being able to locate those, okay? So in the next video, we're gonna take a look at addition, subtraction, and scalar multiplication. So we'll do some operations kind of like we did for vectors. So I'll see you back here.